So in this section, we're going to be talking about proportions and variation. So first off, when we have a quotient of two numbers, we call that a ratio. And when we have an equation that states that two ratios are equal, it's called a proportion. And to solve these, notice that we could multiply both sides by 5. And now this would cancel out here. But we also want to get rid of this 3, so we can multiply both sides by 3. And then these 3's would cancel. And we're left with 10x equals 3x. Get our x's on the same side. And there we go. On this one, let's start by seeing x can't be 0 or -3 because then our denominators would be 0. So we can't have either of those for solutions. So we're going to cross multiply, which is essentially what we did here. So multiply both sides by x plus 3 and by x. And what happens is on the left side, these will cancel, and on the right side, these will cancel. And we're left with x plus 3 times x minus 1 equals x times x. And now we just need to distribute. Since we have x squared, set it equal to 0. And now we just have a first degree equation, so we solve these like we did in chapter 1. And now let's check. Our answer is 3 halves. Notice those were not either of the numbers we can't have for our answer. So we are good. On this one, notice we're already stating x can't be -2. So when we cross multiply, on this side we'll be left with 3x plus 1 times x plus 2. And on the right side we'll be left with x times 12. Distribute. And now we do have a squared term, so we need to get it equal to 0. And this will factor. Neither one of these were what we can't have for our answer, so they both would work. Now, some proportions. If we have 8 large pumpkins and we know they cost $38, we want to know how much will 5 pumpkins cost. So we can set up a proportion here. We know 8 pumpkins is going to cost us $38. Well, the pumpkins are going to be the same cost, so we want to know how much 5 pumpkins will cost what. So we can call that x. Well, now we just have to cross multiply, and I'm going to work on the right side. So we'll have 8x equals 5 times 38, which is 190. When we divide both sides by x, we get $23.75. So at this going rate for the pumpkins, 5 pumpkins will cost us $23.75. Same thing here. We have a map, and maps will always have a scale. And it'll say, like, for example, this one, every 2 inches represents 40 miles. So on the map, we have 2 towns, and they're 7 inches apart. I want to know how many miles are actually between the towns if we are going to travel them. So we know our ratio is 2 inches is the same as 40 miles in real life. And so, if we've got 7 inches on the map, that's how many miles? When we cross multiply, we'll have 2x equals 280, or x equals 140 miles. So now, here we've got a flagpole. And we know its shadow is 15 feet. We also have a person who's 5 feet 6 inches, so 5.5 feet tall, and her shadow is 4 feet. We want to know how tall is the flagpole. That means here's our variable. That's what we don't know. And so we've got the height of our flagpole and its shadow is going to be the same rate as the height of our person with her shadow. When we cross multiply, we'll get 4x equals 82.5. So our x is 20.63 feet. For direct variation, if y varies directly as x, that means they're different only by this constant. So if we have b varies directly, so b varies directly with twice r, that means it varies with some constant k. Twice r is 2r, and so when we rewrite that, we can write that as 2kr. Similarly, we've got inverse variation. And so now, notice we've got this fraction here. So inverse variation means we've got some constant over what it's inversely related to. So this time we'll have c varies inversely, so we'll have our constant in our numerator, with the square, and that should be of 5. So of 5 squared, or 25. And that takes care of proportion and variation.